Okay, so today in class, you figured out a way to determine the distance between 2 points, and we did that using Pythagorean theorem. And you chose your points and got the distance. But what we want to do is we want to figure out a formula so that we can calculate the length of a line segment for any points, not just the points that you choose, and so we don't have to continue to do Pythagorean theorem. So we're going to develop a formula for the length of a line segment right now, using the same idea that you did today in class. So what I'm going to do is I'm going to choose 2 points, and I'm just going to call them A, and that's going to be my point there, and I'm going to put B over here. So A and B just represent any 2 points on my Cartesian plane. And because they represent just any 2 points, I'm going to call A x1 and y1. So I don't really have actual points for A. It's not the point 2, 3 or 5, 7. It's just x1 and y1, the first x value and the first y value that matches it. And B I'm going to call x2, y2. Just like that. Okay, so AB is our line segment, and what we're looking for is how long is this line segment? L standing for the length. This is also used to calculate how far it is to get from A to B. That's the same as how long the line segment might be. So what we're trying to do is to find that length, but in order to find that length, let's do what we did today in class. Let's drop a perpendicular down here from B and over here to A, so that we form a right angle triangle, just like we did in class. And we're going to form a new point here, and we're going to call that new point C. Now let's take a look at what the coordinates of C are. We could call it x3, y3, but actually C is already related to some of the points that we know here. So this is x1 on my x-axis, and this is x2 on my x-axis. Which one matches up with C? Well, x2. So C has the same x value as B. So C is going to be x2. And the y values, this is y1 on the y-axis. And across here, this is where y2 would fall on the x-axis. So C is going to have a y-coordinate of y1. So it's going to have the same x-coordinate as B and the same y-coordinate as C. Okay, so let's take a look at what AB actually is. Let's use this as our right angle triangle. Okay, so this is our right angle triangle. So we know using our right angle triangle that a squared plus b squared equals c squared. That's Pythagorean theorem. So in this case, I'm going to put what we're looking for, which is our L squared. So we're going to use, like I said, Pythagorean theorem. So a squared plus b squared equals c squared. So a squared and b squared, of course, those are our legs. Those are our 2 shorter sides. So we're going to call this ac squared. That's this length across here. And we're going to add that to bc squared. And that result, of course, should give us AB squared. And just for fun, I'm going to rearrange this equation. I'm going to do that down here. So I'm just going to put the hypotenuse first, because that's what we're looking for. So AB squared is equal to AC squared plus BC squared. Good. And instead of calling this AB squared, I've also labeled it L. So this is now also going to become L squared. All right, let's take a look at this. AC is the distance to walk along here. Well, we recognize today that that's the distance to go from x1 to x2. So it's the distance between x2 and x1. And to calculate the distance between things, we would just subtract that distance like we did in class today. So AC can also be written as the larger x value subtract the smaller x value. Like that. And then, of course, BC in the same way could be written as So BC is this length here. It's how far I have to travel from y1 to y2. So it's the larger y value, y2, subtract the smaller y value. And of course it's squared because BC was squared. Well, that's what's going to give us our length squared. But I want to determine an equation for the length of a line segment. And to determine the equation of a length of a line segment, we need length by itself. So the last step I'm going to do is just take the square root of both sides. And so it turns out that, therefore, the length of a line segment can be written as the square root of the second x value minus the first, that distance squared, plus the second y value minus the first, that distance squared. And this, let me get a highlighter out because it's very exciting stuff. Let's go pink. This right here is the formula for the length of a line segment. So if ever you're given any 2 points and you have to calculate the distance between those 2 points or how long that line segment is, you're going to use this formula right here. So copy it down and I'm going to give you a quick example. Okay? All right, so let's go back to, let me get my marker out here. Okay, so let's say that you're given the question that says, for example, calculate the distance between point P, which we're going to say is -4 and 7, and point Q, which we're going to say is -3 and 1. So using my length formula, which can also tell me the distance between 2 points, because the length of a line segment and the distance between 2 points will be the same, I can set this up like this. I know that the distance between PQ is going to be the square root of the second x value subtract the first, or the difference between the x values, squared. Because remember, this came from Pythagorean theorem. And then the distance, or yeah, the difference between the two y values squared. So now I can plug in what I know. So it's still going to be the square root. Make sure you keep writing that square root sign down. A lot of people get that lost along the way. I'm going to take my second x value, which is -3. You know what? It really doesn't matter which one you put first. If you choose this as x2, that's okay. Okay, so -3 subtract, because that's the subtract sign, but then my first x value is -4. So now we're dealing with integers here. -3 subtract -4, close the brackets, don't forget that squared sign. That's the first part. Plus the second y value, which was 1. Subtract the first y value, which was 7, and I'm going to square that. And now I just do the math. Don't forget the square root sign. You have to write it down on every step. -3 subtract -4. So I do what's in the brackets first. Now, quick hint, some of you, I've helped you out in class with this. I don't like seeing two negatives beside each other. That makes me confused. Two any operations beside each other. So whenever I see two signs beside each other, I change it to 1. If the signs are the same, it changes to a plus sign. If the signs are different, it changes to a minus sign. Okay, so back to black. There we go. So this inside my bracket is now going to become -3 plus 4 squared. And this inside my bracket, I could do the math right away because there's only one operation going on. 1 minus 7 is -6 squared. Good. Okay, keep going. So now I've got -3 plus 4 squared. -3 plus 4, of course, is 1. And 1 squared is 1. Good. Plus -6 squared is -6 times -6. So if I multiply two negatives together, I get positive. So it's 1 plus 36. And because these are both being squared, your answers are always going to be positive because we're squaring. So if you have a negative and you're squaring it, it's going to be a positive. So if it's not a positive, you've made a mistake. Okay, let's keep going. So I'm just running out of room here, so I'm going to erase the rest of that sign. There we go. So now I've got the square root of 1 plus 36. Well, I know that that's 37 underneath the square root sign. And 37 is not a perfect square. I can't take a perfect square of it. I would get a decimal if I punched that into my calculator. And so this is an exact answer. And so we're going to stick with it. Unless it's an application question that asks you an actual distance to a decimal place or two, leave it exact. So root 37 is an excellent answer for this. So therefore, the distance between points P and point Q is the square root of 37. If you want to see what that looks like, the square root of 37 is 6 and a little bit, 6 point something. But I'm not interested in that. The square root of 37 works just fine with me. It's a perfect answer. Let's go with it. Okay, so make sure you understand this. Write down any questions that you might have. Bring them to class tomorrow, and we'll do some practice with this tomorrow in class. Okay.